All right, with this set of notes, hopefully we're going to be able to apply some of the stuff we learned in the last set, and we'll hopefully learn a little bit of new stuff about circuits. And if you know some already, hopefully it'll be a good refresher. On this first one, I want you guys to work through it. First, show me the direction of current. Then show me on the battery which end is positive 6 volts and which end is 0 volts. Then I want you to show me how energy changes. So tell me about the form the energy takes as it cycles through the circuit. So go ahead, try it out, and we'll be back in just a second to go over it. All right, so when we draw our battery here, hopefully we notice that the positive side is the big side, so that's where 6 volts will be. The negative side is 0. And because of that, conventional current flows from high voltage to low, so it should be rotating that way. As it does that, in the battery, it is chemical/electric potential. That's where the electric potential comes, is from the chemical energy. It pushes the electrons to move, so as they're moving, that's kinetic energy. And some of that energy on the way over, especially in the resistor, it's going to bump into it and it's going to rub, and that friction creates thermal energy. So this is going to be how energy gets transferred as it goes through. Now let's move into talking about power. Power is basically just the amount of energy over an amount of time. So change in energy over change in time. Well, from our unit on electricity, we know that delta U, at least for electrons or any charged particle, is going to be the change in voltage that it goes through times the charge of the particle. So when we plug that back into this equation, what we get is delta V Q over delta T. Well, we know that Q over T is the same thing as current, right? So this right here, amount of charge per amount of time, is current, so I get delta V I. So it's going to be that power is equal to voltage times current, which if we use Ohm's law to rearrange it, we can get 3 different equations for it, one of which is V squared over R. If we replace I is equal to V over R. Or if we replace V, what we should get is I squared over R, because V equals IR. So when we do that, this is what we get for equations for power. So the total energy dissipated by a system then, so this is E, your change in total energy is just going to be equal to your power times the total amount of time you're doing it. Cool beans.